Hey everyone, welcome to our first stats video. This one's a review of mean, median, mode, and range. Let's see what that's all about. Alright, so first of all in this video, before we can start, we got to understand when they say the word distribution in a stats problem, they're just talking about a set of values that they've given you to look at. So sometimes in a stats problem, a distribution could be a group of students' test scores, or a bunch of runners' times in a race, or the height of a bunch of trees in a forest. Anyways, you get the idea. That's what the word distribution means in these questions. So first up, we're going to talk about something called the mean of a distribution. Now, mean is just a different way to say the average of a set of values. To calculate the mean or the average, all we have to do is add up all the values in a distribution, find the total or the sum of all those values when we add them all up, and then divide that number by the number of values that we just added together, like in this example. So remember, all I did there was add those values together, press equals, and divide by the number of values in the list. Two common mistakes. People often forget to press equals after adding that last number in the list. And don't forget, the number you're dividing by is the number of values that you added together. You could just count them in the list, and that's what you're dividing by. Next up is median. The median in a distribution is the number that sits right in the middle of that list. But on this one, the list has to be in order. So you've got to rank the values in order from least to greatest. And then the middle number is the median. Now, to find the median, the easiest way is usually to count in from either end of the distribution, crossing off one number at a time until hopefully there's only one number left in the middle. And that number that's left right in the middle, that's the median. Now, if we have two numbers left in the middle after crossing off from either end, like in this example, then all we have to do is add those two numbers together and divide by 2, or find the average of those two middle numbers. And that number that we just calculated is the median. Next up here is the mode of a distribution. Now, the mode of a distribution is just the most common value that occurs in the list. Now, usually there's just one mode, like in this example. But there could be more than one mode, meaning there's more than one value that shows up the same number of times. Like in this example, and in this one. And it's possible, although unlikely if they're asking you to find the mode, that there's no mode at all, meaning no value repeats in a distribution. And last up, we have range. Now, range is a term that's kind of exactly how it sounds. It means the difference between the highest and the lowest value in a distribution. So once you find your largest number and your smallest number, subtract the little one from the bigger one, the smallest from the biggest, and what you got there, the difference, is the range. Just like in this example. Now let's see one more example of each of these, mean, median, mode, and range, to make sure we're all clear.
Alright guys, welcome to the instructional video on the mean. And the first thing I want to point out to you is that word mean up there and what it actually means. Mean is really just a fancy word for average. And you're all familiar with averages. You get them when you calculate your average at the end of term, and the way you do that is really simply to take any series of numbers and add them all up and then divide by the number of numbers that you have. So a couple of things before we get started. Just the symbol for mean. And the symbol for mean is always going to be that little X with a bar over it. And that's what we're going to use to represent the word mean or the word average. And the way that we're going to go ahead and get the mean is to take each of these numbers and add them together. So I'm going to go -4 plus 42 plus 10 plus 0. I'm going to come back, talk to you about that one afterwards. Plus, and you have to be careful here, -35. And when I'm writing out my solutions, I like to use brackets to offset that negative. Now, I'm going to have to do a division afterwards, and I'm going to divide by the number of data points that are in the set. And in this particular set, right here, if you count them, we have 1, 2, 3, 4, 5. We're going to divide by 5. Now, I want to point out to you that that number 0 still counts as one of the numbers. And you think about it, if you got a 0 in one of your classes, God forbid, that would really affect your average. It would bring your average way down to take a 0 as one of your subjects. And so it's the same thing in any set of numbers. You have to use all the numbers. Don't get fooled that that 0 counts. That's why we added it. We know it didn't affect the sum, but it does impact the value of the number on the bottom of the fraction. In other words, that 5. We're not going to divide by 1, 2, 3, 4. We have to divide by 5. We're going to include that 0. So now over to the calculator. You got to be careful with your calculator about the order in which you push your buttons to see how you make that 4 a negative. Some calculators make you push it first, the negative button first, like this one here. Others make you put the 4 and then switch it to a negative. You have to experiment with yours to try that out. Plus 42, plus 10, plus 0, which I know isn't going to change the number, but I'll put it in there. Plus, and then -35. Be very careful about that. Adding, you can see it right here, plus the -35. And when I do that, I'm going to get 13 for the top of that fraction. And now I still have to remember that I need to divide that by 5. And then hit equals, and you get 2.6. So the mean, or the average, of this set of numbers is 2.6. Okay, so you just add up all the top, hit equals to get that sum of 13, and then divide by 5 in this case, and simplify, and you're done. So just as a reminder, don't forget that that 0 is one of the 5, and you'll be good. Hey guys, this is the instructional video for median, and just a quick note on the word median. Median is really just another way of saying middle. So in this case, the middle number or the middle value from a set of numbers, in this case the numbers that are located right over here. And in order to find the middle, we're just going to kind of count in, and I'll show you the technique for doing that. But before we do it, we have to first note that the numbers themselves must be ranked. In other words, they have to go from lowest to highest. And if you ask yourself, are these numbers here ranked? You can see right away that they're not, right? You can see this -20 way over here when it really probably should be the first one in the set of numbers. And so the first thing I'm going to do is I'm going to rewrite those numbers from my set in order from smallest to largest. And I'll keep track as I go. So the -20 is going to be the first one to go. And I'll scratch him out. And then I'm going to look for the next smallest number, which is in this case -14. Scratch him out. And then the next lowest number is going to be the -5, -3, -2. I think we're in deposit territory now. We are, and oh, there's the number 1, which I'll have followed up with a 5. And then I'm looking at the 8, and then the 12, and then that 13, right? The 8, the 12, and the 13. And now I can see I have all my numbers nicely arranged from the lowest all the way up to the highest. And so the next step, in order to find the middle number, is really easy. We're just going to start scratching values out from both sides, working our way into the middle from this direction and from this direction at the same time until we're left with one number in the middle. And so I'm going to scratch out the negative 20, and I'm going to scratch out the 13. And I'm going to keep working my way in until I find the one that's right in the middle. And when we get to this point now, I want you to notice that we've got a little bit of a problem, because we have two numbers in the middle. Now, the reason that happened is because we actually have an even number of data points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points. And when you have an even number of data, you're never going to have one number in the middle. If this was 9 numbers, then we'd have 1 left in the middle. Any odd number would have 1 in the middle, and that would be your median, that would be your middle number. It's very easy. But in the instance when you come down to a spot where you're left with 2 in the middle, because we have an even number of points, we can't say that the median will be equal to a negative 2 and a 1. It doesn't make sense. We want a middle number. And so what we do to get the median when we have two middle numbers is we get the average of that middle 2. So we're going to go negative 2 plus 1, and then we're going to divide that by 2 because there are two numbers there. So we remember when we were calculating for our average how we work that. Negative 2 plus 1 is negative 1 over 2, equal to negative 0.5. And so for this distribution, rather than one middle number, what we have is the middle two numbers averaged, and that value right there will be our median. Hey guys, this is the instructional video for mode. You can see the question here, what is the mode of the following data set? And mode is really just a mathematician's word for most frequent. In other words, is there a number here that repeats the most often? And the number that repeats the most often is called the mode or the modal number. And so all you have to do when we're looking for the mode is to just keep track of how many of each of the numbers do you have. So for example, you'll see the negative 5 over here. We have that one 2 times. And whereas we only have one negative 2. And as you continue to analyze those data points, I want you to notice over here we have the number 10 3 times. And no other number repeats itself 3 times. Now it's very handy, just like with the median, that we make sure that our numbers are ranked when we're looking for mode, not because the order matters so much, but because it's a way of making sure that the numbers will be grouped properly, right? If you have all your 10s in a row and all your negative 5s in a row, it's really easy to see which ones repeat the most frequently. So there are 2 things that I want to point out to you that might come up with other styles of questions. And that is the following. In this case, the number 10 is the mode, and it's the mode because it repeats the most frequently. So the 2 things that I want to point out to you is that number negative 5, although it happens twice, that's not enough to make it the mode in this case. The reason is because I have 3 10s. So it's not enough just to repeat. It has to repeat more than any other number for it to be the mode. 10 is the mode because it repeats the most often with 3 times. The second thing to keep in mind, though, is in some instances, sometimes a set of data points will have a tie. In other words, if you imagine for a second that I take out that 10 right over there, now instead of 3 times, I would only have 2 10s, and I would have 2 negative 5s. And in that instance, you might ask yourself, well, what do you do when there's a tie? Right? When there's a tie, what happens? Well, the answer for the mode is a little different than it was for the median. For the median, we took the average of the middle 2. But when there's a mode question and you have a tie, then the answer is you have 2 modes. In other words, if I didn't have this 10 here, this question would have 2 answers, the negative 5 and the 10, because I would have 2 of each of those and no other number repeated so often. But in this case, for this particular problem, we can stop right away and say that the answer is 10, because, as I said earlier, there is only one number that repeats as often as the number 10. That's 3 times, and there's your answer. Okay, but do be careful about what happens when there's a tie, just in case it should come up in another question. Hey guys, this is the instructional video for range, and the thing you need to know about range is it's really just a question of knowing what your biggest number is, your biggest value, minus your smallest value. In other words, for range, what we're trying to learn is how far apart are the extremes of any set of data in any set of points in your data. So when you look at the data, it's really important. I want you to notice that this one is not in order, and they're intentionally all mixed up. And so you have to be very careful when you're doing these to make sure that you identify correctly the smallest possible value and your largest possible value. So I'm going to start by looking for the biggest possible number. And when you go through this set of data here, you're going to notice for me, off the top, that's 16. That's going to be your biggest one. No one's bigger than 16 in the data points, and I'll just check one more time to make sure. And sure enough, that is your biggest number. And now I'm going to look for the smallest number. And since there's some negatives in here, obviously we're going to want the largest negative number to be the smallest number. And that's right over here. Negative 22 is as small or as low as this distribution gets. And so to do the range, all we have to do is say, okay, range will be equal to big minus small. And that means that in this case, the range will be equal to 16 minus, now here you have to be careful, negative 22. And that can be a calculator issue. I'll show you how it works on my calculator over here, and I'll show you a trick to make sure you never make a mistake on your calculator, regardless of how yours calculates. But if you think about it, remember, you've been trained on this one that when we subtract the negative, what's really happening is you end up adding those numbers together. But to show you, on this calculator, I'm going to go 16 minus, and then I have to push the negative in front of that 22. And you can notice that this calculator distinguishes between the minus and the negative by making the negative a little bit smaller. And in this calculator, I have to put the negative in before I push the 22. Other calculators work differently. You have to experiment with yours to see which way that works. And then you cannot forget to hit that equal sign. Now, when you do that, you get an answer of 38. If you want to be sure that you're not messing up over here with this negative business, then do what I did on paper on your calculator. Let me show you. Come over and you hit that 16, and then you're going to go minus, and then open up your brackets. You can see that little bracket right there, and then put in your negative 22, close that bracket, and then hit equals. And you'll see you get that 38 once again. Now, I don't need to use brackets on this particular brand of calculator, and if you're working with this Casio, the same as mine, then you're okay. But if you're using a different calculator and your numbers when you're doing your problem aren't coming out like mine, then try that bracket in your calculations, and it should work just fine. Okay. Last thing I'll say about range, a really useful analogy for thinking about range is to be thinking about things like temperature. Temperature is a really nice way of working with range because it includes both positive numbers like 16 and negative numbers like negative 22. And so if you think about, let's say, I don't know, a place in the world where the warmest day of the year was 16 degrees and the coldest day of the year was negative 22, then the range in those temperatures is 38. 38 degrees of temperature would separate, the coldest day from the hottest day. That's a nice way of thinking about those points in the data set when we're working with range.